Good afternoon, everybody.
Good afternoon.
So today we'll talk about just going through a few of the basics of what R is, what Rstudio is, what Rstudio Cloud is, and we'll eventually go to Rmarkdown. And we'll cover some topics to play around with for doing some analysis in R. We'll just keep it simple, but that is what I had in mind for today. I think we'll run out of time. Okay. So what is R? Essentially, it's a programming language for statistics. So whereas with a normal programming language, it could be quite general in the sense that you could make iPhone applications or programs that run on your computer, which are, as a language, quite general. R is very specialized in the sense that it's really made for statistics, and if you've already installed R, it looks something like this. You have on your right side a console, and on your left side I've shown a scripting file. So when you first start R, you're greeted with actually, I'll quit this. I'll start it from the beginning because I really want to show what it looks like when you first start it up. Yeah. So when you start it up, it's this, right? You've tried this, and you're like, what is this? So this is essentially what they call this is a console, and in the console you can type your commands. So in the very, very, very basic form, this is just a calculator. So you can do 1 + 1. Is this visible to you?
Yes.
Yeah?
Yes.
Cool. So we can, of course, use this as a calculator, but this is not very useful. The thing with programming languages is the fact that you assign values to variables. So you can make a variable, I will call it var, and I could tell that the value associated to this variable is 1. So if I run this by hitting enter, the value 1 is assigned to the variable I created, which is var. It doesn't need to be var, it could be anything, it could be apple. And I can assign it a 4. And now I can use these variables. I can call these variables first. So, and I'll get back 1. Or I could call the variable apple, and I will get 4. Easy, right? So what will happen if I do this? What will be the result? Any idea? So now you have to leave your audio on, right?
Will be 5.
Very good. That's it. It's easy. I told you we were going at this from the basics. So I will create a new variable, and I will use a notation within R, which goes something like this. I will use a variable. I will call the variable x, and I will use this notation, which is this. And this notation will result in values 1 to 10 assigned to the variable x. So if I do this and I call x, this is what's the result. Is that clear?
Yeah.
So what will happen if I multiply apple with x? What will be the result?
4, 8, 12.
Everybody agrees?
Will be the same.
Here we go. So what we see is that the variable apple is applied to each value in, that's what we call a vector, a series of numbers. So, for example, no, this is clear. So it's, you apply this whole vector of number, and the multiplication is added to this set, in essence. We also have some indexing. So if we just call apple, if we just call x, we have all the 10 numbers shown, but we can also index a specific number. So the index for a vector of numbers is the numbering of, so this is the first value in my vector, this is the second value in my vector, the third, the fourth, the fifth, etc., right? So if I want the 10th value in x, I will get 10. So now I'll change this a bit, so to make this more clear, I hope. Now I'm going to do this. What will happen here?
You are creating a new apple.
Yeah. Is it a new one?
No, it's the 10 times 4, it's 40, right?
So we're going to multiply apple, which has a value of 4, with x, which has values 1 to 10.
Mm-hmm.
And I'm going to assign it again to apple. So it's not going to create a new variable apple, but it's going to update the content of the variable, right?
Okay.
So if I apply this, I have apple, and it now has, now has the values 4, 8, 12, 16, etc., right? The multiplications of 4. But the original vector of 1 to 10, which was assigned to x, still exists. Oh, sorry, x. But the value of 4, which was assigned previously to apple, is now gone because I've overwritten apple. Is that clear?
Yes.
Yeah. Okay. Now, one of the things with the console is that it's okay to type in such a console, but when I want to rerun code, for example, I want apple to be 4 again, I can scroll up and see that, oh yeah, I've assigned 4 to apple here, so if I want to do that again, I have to rewrite it. Or go up in my history, find the place where I assigned 4 to apple, and then run that again, and we're still in apple here. And that's not very convenient. So with mostly all programming language, you actually write your code in a text document, which is a script. It's called a script. And R also provides this. You have a script here on the left where you can create your code. X is, let's say X is 4 and Y is 3. And I can run this code by selecting it and running it. And what happens here is that the text that you've written here will be run in the console. And I can store this file. So in terms of reuse, I can reuse this file at a later date. And I can also say, well, I want to multiply X with Y. And I can just store all my scripts, everything that I write, in R. So that's fundamentally the basics of what you do with programming. So you have a script file where you define your variables, you make operations on those variables, you store it in essentially just a text file, and go back to that when you need it. Now the problem with just using plain R, as you've seen here, is that it doesn't provide much additional functionality. You have if you use it in this raw mode, you just have these two windows, a console and the scripting file, and that is where Rstudio comes in, because Rstudio builds upon the programming language R, but adds, as they call, an integrated development environment. So it features the same functionality, but it adds upon the functionality of just plain R, and we'll also have a look at that. So if we go here, I've got Rstudio running, and we essentially see in the left column the same two things. We have at the bottom left for you the console, where I can still write code. I can still say x is 3, and I can call x, and it will show what the value of that x actually is. And my script file is up here, where I can just start typing the same kinds of code, just as a text file. X is 3, and I can run that again. So it provides the same kind of functionality as R, but you have a few more options. Rstudio also provides what they call code highlighting. So we see that the 3 is blue here, and if you use more code, it will highlight different types of strings that you've used in your document. It also provides you the capabilities of creating a view on your plots. It shows you where you are in your file system. It provides you with help functionality. It integrates with other kinds of applications. And as we will see today, we'll transition into using Rmarkdown to combine the statistical computing power of R with a more HTML web-based presentation of results. We'll go into that later. So Rstudio Cloud, transitioning into that, is essentially a cloud-based variant of Rstudio. So where you can run Rstudio on your desktop, Rstudio Cloud is the same, actually the same as Rstudio, but just in your browser, and it offers some added functionality for working together. So in terms of what you should use if you really want to start using R, I would advise to just install Rstudio on your personal computer, because that's the fastest. The reason why Rstudio Cloud was created is because, especially for teaching, first getting to set up R and Rstudio and making everything work takes up a lot of time. So especially for teaching, just using Rstudio Cloud will have the Rstudio environment available to your students without the need for additional installation of software on your system. So you can just go into this pretty fast. I've added a link to Min presentation on on Rstudio Cloud, and that's one of the points that she makes, that normally she would, when teaching R, it will take up a lot of time to install the software and get everything up and running before you can actually get to the content of your course. So Rstudio Cloud is basically the same environment. This is Rstudio Cloud I've created for us today, and we'll try to see if it works. An environment where I have my presentation also running. So this presentation that you're looking at here is also created in R, but also with Rmarkdown, which is in a project presentation. And if I open this project, it will take a while. I told you Rstudio Cloud is a bit slow. It will actually open the Rstudio environment in a cloud setting where every functionality of Rstudio is just available. It just goes a little bit slower. So this is my presentation, which I've written today in Rmarkdown, where I have a title, I have a subtitle, I have just some text. I introduced myself today. We're talking about R and Rstudio and Rstudio Cloud. So the next topic is Rmarkdown, and this is when we're talking about Rmarkdown. It's integrating R with Markdown. Markdown is essentially a markup language, very basic. If you add something to a wiki page, it's the markup is a little bit the same, in the sense that if you want to have a header, you just add a hashtag, and then you have a header. If you add 2 hashtags, then you have a second level header. So the markup for the text that you're writing is very simple in that sense. The thing that is added with using Rmarkdown is that it integrates both. So you can use the very simple markup language of just having a header and a text, and also providing R code, which will get executed, and the results will be shown as the result. So what we're looking at here, everything, it's just plain text until we come to this part where we will go in later. We have here a chunk of code which is indicated by that it's R code here, and within this chunk you can run R code, and it will run the analysis or the script that you're using, and it will provide the results as output in your HTML document. So in this example, I'm using the IO slides presentation as output, but as you can see from Rmarkdown, you can output to HTML, but also to PDF or Microsoft Word. And there are many more options of outputting your files, your raw content, to different file types. So you have a lot of variation and a lot of different destinations as possible output formats for Rmarkdown. So that is essentially what Rmarkdown does. It combines the scripting capabilities of R with just plain text. You could also easily change this, so you could change this from IO slides presentation to just an HTML document, and you would have an HTML output instead of a presentation slide, which I have here. So if I reload this one, this is just a presentation, and I think from the top of my head, like HTML documents, HTML underscore documents. I'm not sure now. Let's see if this works. I will run this. Yep. And if I go to the same page that I created where we had our entire presentation and reload this, because it's just a web page, it's just HTML, it will show up differently. So this is what we'll be looking at the rest of the day. But well, this is not very pretty for presentation, so I'll try to get it back to the original format. Yeah, here we are. I'll rerun this by pressing the knit from knitting button, and it will relaunch the page, build the page from scratch again. When I reload this, we're back in the presentation. So these are some of the capabilities of what you can do with Rmarkdown, combining R and Markdown. So what I'm going to try now is get you into the same environment as I'm working in here, so you could play around with it a bit. So we're going back in here, and this would provide you a URL, a short URL, which I will share with you. You can type it, or I will drop it in the chat. Let's see the chats. So I've shared in the meantime the link with you. Were you able to get into the Rstudio environment?
Yeah.
Yes.
Yeah. Okay. Cool.
Oh, certainly.
Yeah. So I see that you've also had, in my view here, I can see that you've created based on my assignment, because I made my presentation into an assignment, so you could copy it and just play with it, play around with it for yourselves. I see you now have also the presentation available. So I'm starting the presentation, the code again. So you have file, and within file you have the ability to open a new R script, or oh, that went too fast, or an Rmarkdown, which we'll be looking at today. And you see there are all other kinds of scripts that you can use for your presentations or for your research output. So if you click a new Rmarkdown file, it will ask you to name the file, and it will also ask you what kind of output format you want. So do you just want HTML or PDF or Word? It will also show you the option to go to create a presentation. And for my presentation, I opted for HTML IO slides. But there are also other options. You could even create a PowerPoint based on these results. So if you go just for documents, I'll create a test for now. It will create a new file, an untitled file, which has some pre-formatted outputs in Rmarkdown. So you actually never create, if you go through this route, create a total blank file. And for me, this was quite handy, mostly because we always have at least something to look at and see, oh yeah, this is how it's supposed to be done. So it's also a reminder on how it works.
What could I do with this now? So I did the exact same thing that you were doing, but how can I see this file?
Yeah, so I now created a new file. It's untitled still. And if I want to create an HTML file based on this results, I first have to save it. So it asks me to save it in my document folder, so I'll call it tests.
Yeah.
I'll save it, and you see at the right bottom window
yeah.
that test RMD is created. RMD
Mhm.
stands for Rmarkdown, of course.
Mhm.
And now by clicking the knit button, it will create an HTML file, which will also show up in your document structure here.
Which button? Knit?
This one.
Oh yeah.
Do you
Oh yeah, I see it. Yeah.
Yeah. So it's the knit button, and that will create the HTML. And you can, if you click on it, it asks you to open in the editor or in a web browser. It will when you run it, it will probably have a pop-up window with
Yeah.
the results of the
Yeah.
of your.
It does.
Yeah,
Yeah.
exactly.
Great, thank you.
I'm going back to the presentation for now. So you now at least have an environment for yourself to look at and to run the code. So that's good. Just play around with it. You can change some values in here. We'll go into to some summary and plots, statistics later on. So let's see where we are. Yeah, so I just wanted to focus your attention on some free resources. The R for Data Science is a quite comprehensive resource written by the Rstudio team on how to use R, of course, for data science. It's actually written in Rmarkdown and compiled to what they call bookdown. Let's see if I can open this one. Yeah, I can. So it also means that you can use Rmarkdown to, well, actually essentially create a complete book with images, with plots, with references in them, with the ability to even, sometimes to even download the PDF or an EPUB version of the book. So it's a very simple language to learn, which has a lot of capabilities. So if you want to learn R, the data science part, it goes into every bit of detail on how to create all kinds of plots, interactive plots. Yeah, you name it. Mostly everything is possible. So that's a resource that I wanted to show you. The other one is also written in Bookdown, in Rmarkdown, is the complete guide to Rmarkdown, which has the complete reference of everything that you can do with Rmarkdown, going from the basics to also the various output methods that you have. So you could have HTML documents, you can have HTML documents with a floating table of contents, you can change styles, you can change essentially everything based on some parameters that you can give each page. You can even have tabbed pages, as you can see here. But it also shows you information on if you don't just want to use the HTML but want to use a notebook, it has the explanation of what that does exactly. If you want PDF as output, Word, or you want to use the presentation styles, using IO slides and all the things that are possible within IO slides, or all the different packages. So I've shared that one with you. And the last one is an iBook. I don't know if you use iOS. It's the Introduction to Data Science. It's also a free one, and it uses R, but it also explains a multitude of use cases where you can use R also for text mining to try to get for analysis. So it has more real world examples in it. So those are 3 resources where I think it's good to know these. A final one, let's see. No, I want to go back. So there's one more resource that I wanted to show you, and that is you have the help within Rstudio. So did you see that? If you go to the right bottom tab, help, then you have the help files of R available to you here. And these can be a bit cryptic sometimes. So when you use R more and more, you'll get used to the way these documents are structured. So for example, if I wanted to know something about the function correlation, which is called the correlation, the function called correlation core, it describes what the input is for a correlation analysis within R. So you have input X and Y. You have a few use cases. So you can use everything, or this is an example with everything. But if you look at use as a parameter of the function, you can see here what are the options. So you can use everything, or all observed, or complete observed, or NA or complete, pairwise complete. Do you see the relation, for example, with the Stata or SPSS? So in SPSS you can also do an analysis and describe what to do with missing values, or for which values to use. So for example, if you do a correlation, you have 2 vectors with numbers, and if in one vector one observation is missing, do you omit the total results, or do you omit the entire variable? So these kinds of options you can specify in your function. And if we're looking at the methods, you can choose for the Pearson correlation, the Kendall-Taut correlation, or the Spearman correlation. So you see that the help files provide you with an example. It describes the various options that you have within a function. And at the end, it also has a few use cases with examples that you can run in R. So that's useful, but I understand that it can be a bit daunting. What you could also do is use a question mark in your console. So this is at the bottom left. I don't know if you can see this.
Mm-hmm.
And you can type in the function that you're looking for. So if I want some help on the function, let's say table, I can run this, and it will pop up the help results to my right.
Okay.
Yeah?
Yeah, thanks.
Okay. Okay. So what I wanted to do in the example, I thought I could think of an example, but I thought it might be nicer if we think of the example together to get a data set that we can work on, and that you guys could also work on during my explanation. And I also wanted to use this example to show that the data inputs into R could be more than just loading an Excel file, or a comma separated file, or what have you not. I wanted to show you that with the addition of some packages, which I haven't talked about yet, you could also extend the importing capabilities or extend the overall capabilities of what R can do. So there is this function called rcurl, which lets you import straight from the web. So if you have a URL with a comma-separated file stored somewhere on the web, then you can use this function to get the results straight into R. So what I would like to do is for you guys to think of some continuous predictors to predict some continuous output variable. And what I want to do is I want to create a Google form where we can, where you guys can give the answer. So we will use a questionnaire that we will apply on ourselves. I wanted to see if we could make this happen today. So do you have any ideas of what we could measure within this group? The question for now is, can we make a Google form with 3 questions with 1 outcome variable, which is continuous, and 2 or 3 or maybe more predictor variables, which are continuous. So
do you believe that you can have a Likert scale as a continuous variable?
Yeah, sure. Yeah.
There's some debate about that.
Of course, but at least we can use it. So for all the dependent and independent variables we'll use in this example, of course we don't have any notion on the validity of the stuff we'll be making. So it's just for the example. It doesn't have to be really serious, but if you guys want, then we can do that. Shall I populate the screen with?
Maybe we can work with height and foot size.
Oh yeah, that's really easy. But we have to get out the measuring tapes here then. Yeah.
People just give something.
Yeah. So I'll get the drive dot up. So we'll try this. Okay. So instead of going for a multiple choice question, we would like to have a short answer. What is your height? It's a short answer, and do we have some more options here? So height in what? We have to be more specific, right? We have to
height in meters.
In meters, yeah. Height in meters, it's a number. Yeah. That's good. So we want to add another one. Yeah. Shoe size. How are we going to do this? Because shoe size... Do we gonna use the regular shoe size values?
I would do age, maybe easier, but then there's no correlation. But yeah.
Okay. Yeah. Do you know anything better? Age in years?
Yeah, age in years is also
okay. We'll do age in years. So this is also a short answer, which is a number. Age in years, because you could also do age where you let the participants set their birth date, but if you do that, you have to realize that you have to also take into account the date of administration of the form. And then you have to calculate the difference, so it makes things more complex than are actually needed. Is this enough, or do we think of could think of something else then? Anyone?
You mean another variable?
Yeah.
Maybe weight in kilogram.
Yeah. Weight in kilograms. Okay, it's also a number. Yep. It's okay. I think this is good, right? Shall we use this one? And we'll call this AISSR questionnaire. Yeah. Good. So, what do I want to do? I want the answers to go to a specific spreadsheet. So I don't want the results to get only into the form. I want to get them into a spreadsheet. And I will create a new one? Yeah. Can I change this name? Yeah. AISSR. Make. Check. That worked. This worked. I think we're done. So I want to share this with you guys by link. Make it short. Yeah, that's better. Copy. And I'll drop this in the chat. And you can fill in the form. And while you fill in the form, I hope that I can see the results coming in. Yeah, it works. Completely anonymous. So no GDPR problems here. It's I doubt that I can relate your values to you as a person. But
I have a question whether we're meeting the dependent variable.
Sorry?
There is no size of the shoes, the dependent variable, I mean.
The shoe, weight in kilograms, age, years, and height in meters. So we ditched the shoes, I think, in the progress.
Yeah, we did.
Yeah, we ditched the shoe size because it was too complex. Do we do that in millimeters, or do you use the shoe size? And then do you have Italian shoe sizes which are not the same actual millimeters when you compare that to the Dutch shoes? Okay, it's a whole mess. No, we can't go there. Yeah. Okay, so I think we're done. So this actually means that you can create a questionnaire. You don't have to use Google Forms, of course, but in Qualtrics you could do the same thing and have the data come in gradually and collect everything in there and use this as a source for your output. So I could now download the results from this file, but I could also publish these results with a link. Publish, yeah. And do I want the entire document? No, I only want the first sheet. And I want everything, the results, to be in a comma-separated file format. Yeah. Let's see if we have any more options. Yeah, with this, I think we're done. Okay. So what I'm doing now is copying the link that is generated by the Google spreadsheets where I publish this, and I can use this link within my R code to get the results. So I think I will be going in here. This is my presentation again, and I've I already have examples within my presentation which are based on some data sets that are available within R, but I thought, well, I'll just put this in here. So what I have here is a script which uses the rcurl package. So what it's actually saying here is, if the rcurl package is not installed, install the package, and if it's installed, then load the library. So the way R works, let me say that differently. The way R can be extended upon is by packages that are developed by third parties. So if you are a researcher and you're doing research on some topic, like, well, for me, a computer adaptive testing, and we create a new algorithm that can be used in research, then I could create an R package for doing these analysis with for different kinds of fields, and I could make the package publicly available, and then everybody in the world can use the package. So there are a lot of packages which extend on the capabilities of R, which give it extra functionality, and as you go along in your R journey, you will discover new packages that work very good for you, or maybe write your own packages if you feel like it. So if you follow along in your own version of my presentation, you can go to this specific R chunk and replace the URL with the URL that I've created here. And I'll share this with you in the chat. So this is the URL that I've just created. And I'm pretty psyched that it's working. Hey. So what this does is it uses the rcurl package. I create a variable, just a variable, nothing else, which is the URL. It's in double quotes, which is used to specify that this is not a number but a character string. So this character string is assigned to URL. Then I use the getURL function from the rcurl package and use the actual URL that we just created and assign it to my CSV. It's just another variable. And then I use the function read CSV text connection to the results of this function and assign that to data, and this will result in my data. So these are the data points that I've created. And it's created this data file, and as you can see, we immediately run into a problem, right? Can you see it? What is the problem here?
I think the problem is that some people answered they're 158 meters tall.
Yeah, exactly. So before we can use this, we have to solve this. And well, this is the thing with programming, and the so now we have to try to find out. I didn't plan this because I would, of course, thought everything would go smoothly, but no, without joking, this is what happens when you program. You run into problems and you solve it. So this is a good way to look at well, the problems and what we can do to solve this. So what we need now is we need to change the height in meters. So, and we've seen that data, the variable data, contains everything, right? So where we in our previous examples, we've assigned a specific number to a variable. What we see now is that a whole set of numbers, actually an entire table, has been assigned to a variable. So this variable is actually a data frame. and it contains columns and rows, which, as I alluded to earlier with indexing, you can specify a specific cell within within your data frame by using index numbers. So this would probably show me the results of. Do you agree? Did you see what happened? Can you give me some audio feedback?
I'm not sure I saw what I need to show.
Yeah,
So
I also missed it. What did you do?
Yeah. So the variable that I want to show, if I run just data, it will show me the entire results. But what I want to do now is index. I want to show a specific result. So if I use the indexing, for example, index 1, 2, what will be the result?
First column, second row or something?
Exactly. So which one is that? What are you expecting?
The 19/6/2020
This one, right?
Yeah.
Everybody agrees?
Yeah.
Yes.
Let's see if that happens. We get 1.1.
1.8 or 1.1?
Yeah.
You got
So
sorry,
1.8,
1.8. 1.8.
Yeah,
Yeah.
so we got this one.
Yeah. So what does
Is it-
that mean?
Is it that you're taking the first respondents and the second column in that person's responses?
Exactly. Yeah. So we expected this one. Why? Because our assumption on what is the column and what is the row was flipped around. The first one is the row and the second one is the column. So by using these index numbers, you can target a specific cell value.
Mm-hmm.
I have a question in regards
Yep.
to that. Is it possible to, in an easy way, like assign another column that says like person 1, person 2, and like to replace the timestamps, or not replace necessarily, but like add some ID to each of the respondents?
Yeah. So the question is, can you add columns to the data frame? So
Yeah, for example.
So absolutely, you can do that. And one of the ways that you can do that is, I'll finish the indexing first, because I now specifically asked for first row, second column. But if you leave the first one blank, you will get everything from the second column. Clear?
Mm-hmm.
And if you do it the other way around, you leave the second one blank, then you will get everything from the first row. So selecting everything from the same, from just one column, so that, for example, we select the first column, we get these results. You can use the indexing. So that's very convenient, because within a data frame you can target each and every cell by number. When programming, it can be it can get you into trouble at some points, because maybe at a later date you want to reuse your code and you forgot what the column names were and what the numbers represented. So you could also use, instead of the numbers, you could use the column names, for example. And one way that is used quite often is using a $sign after a data frame. So this data set is a data frame, and I can use a $sign to specify a specific column within my data frame. And because we're using Rstudio as an integrated development environment, it has added functionality. And one of the added functionality is that if I use this $sign, it shows me which variable names are available as column names. So here I can just choose height in meters. So instead of making the index very specific with numbers, I could also say, well, just show me the results of this column, and I get the results of the column. Is that clear?
Clear.
Yeah. So now to get back to the previous questions of can we add a new column with IDs for these people, for example. We can do that in the same way as with the $sign, and we can just create a new variable, for example. And this is a new column. We create a new column within the data set, and we can assign this a value. So what do you think will happen if I do this?
They will all have ID 1.
Yeah. Should we test? We don't see anything because we just applied the 1 to ID. So if you want to see it, we have to call data again, and then we now have an ID. So I want each and every one to have a specific ID. So I might be better off if I change this value 1 to what? What do I need to do you think?
1 to 10?
10.
Yeah, but you did in the beginning.
Yeah. So I could use the this to create a vector with 10 numbers, and then this would result in a specific ID indeed. Yeah. So how would you go about to correct our data? So what can we do? So we concluded that these 3, 1, 2, 3, that they are not good. Or, so what do we do?
Sorry to
We
interrupt,
divide them
Sharon.
by 100.
Yeah, oh, sorry. We have an interruption. Go ahead.
Yeah, I have just a question on the ID column. To add this column, you just did the data $ID. That was it?
Yeah, that's it.
That adds a column. Okay.
Yeah, exactly.
Thanks.
So you now had some time to think about this. What do we do?
You could specify the row and the column, but then if you would load the data again and it's not exactly in the same row and column, then you would have a problem.
Yeah, so you're saying we could go to the problematic, it's row 2 and 2, and then, so now we have a problematic result, right? This one was one of the problems.
Could you just like do the equal sign and just change it to like 1.58?
Yeah, I could. 1.58. Programmatically, would this be a good option?
Not if you have many that are wrong.
That's true. So that is true because it would be a lot of work.
You could index the row 2, 3, 4 and column 2, and then divide the whole thing by 100.
Okay, so you're saying don't just index column row 2, but also 2, 3 and 4. I'm not sure if this will work, but let's see. Yeah, it works. And then
divide the whole thing by 100.
Yeah, cool. Here we are. Are we done? Looks cool.
Probably you need to rename it so that it's I don't know. No, because I think here you just calculated these values divided by 100, so you need to rename it so that it gets integrated into the column, right?
Yeah, so we've only done a calculation here, but we haven't assigned the results of this to anything. So if I look at my data set, it's still the wrong values. So if I want to fix this, if I actually want to assign these values to column 2, row 2, 3, and 4, then I have to assign the result of this to something. To what? So where do I?
To the variable height in meters.
So
And then
so you're saying assign it to the variable height in meters.
And then row 2 to 4.
Okay. Yeah, so you're saying you use the variable height in meters and then assign it to row 2 to 4. Okay. So would this work? I'm asking everyone, eh? So make your brains hurt.
I don't know. Let's press enter and see.
Yeah, okay. That's a good option. Boom. Oh, we got an error. Error in height in meters 2, 4. Data, blah blah blah. Object height in meters not found.
Maybe we should add data dollar height in meter.
Data dollar height in meter. So before we do this, and before I'm going to press enter, I first actually want to know what is the result of this. So I'm going to just look at this. Yeah, this looks good, right? But it also looks the same as this, doesn't it? It's the same. So the trick here is to assign this is the second row, the second column, row the row 2 to 4 of the second column, and what you're writing down here is essentially exactly the same thing. Do you see that? Does everybody see that? Is there anyone who does not see that?
I can see, but come again. I didn't get your point.
So this is the same as this. Here we specified that we're looking at the entire data frame and that we only wanted to look at height in meters at a specific column. And from this, which will turn into a vector with only the height in meters, we're only looking at results 2 to 4. And what we're saying here is that we're looking at the entire data frame. We're looking at row 2 to 4 and only at column 2. And column 2 is actually height in meters.
Yeah?
Yeah?
Yeah.
Great. So we could do this, or we could just say this. So we're replacing what we have in our data set, dividing this with, by 100, and then putting it back in the same spot. So running this will result in our corrected data. We're there. So the point that I wanted to make here, especially with using this form, this way of inputting your data, is that this is live. So if anyone else updates or also fills in this form, you can rerun your script and you'll get updated data, and you'll have your analysis based on the latest version of your data. So you can create your scripts, make sure it does what it's supposed to do, and can even update every time that new data comes along. So we've done this. Let's see if we're back at the presentation, or if I've lost this. Oh, here we are. we've seen the example. Yeah, so I just wanted to make you aware of the fact that for importing data, we have now used the rcurl package, but you could also use for Excel, importing Excel documents, use the read Excel package. And there are built-in read functions in R. So if you go into Rstudio, oh, sorry, let's go here. Sorry. If you start typing, Rstudio will provide you with all the different kinds of read formats that are available in R for you to use. So well, you can import essentially anything into R, but you'll have to dive into it. And I added the data camp as a resource because this reference, here we go, it essentially explains every type of import option that there is available within R. So everything you need will be described on this page. So we used the rcurl package, and well, we can now look at some frequencies, create some plots. So the code that I provided, if you're following along on the topic frequencies, then you see that I've used the summary function, and I used the summary function on the iris dataset, which is a dataset that is available within R, and it's about plants, irises, and it shows the sepal length. But because we now created our own data, we're not interested in that anymore. So now we could opt for something else. We could do the summary of our data, where we essentially want to look, for example, in our height in meters. So I would like the summary of this. So summary is just an R function that you can use on a variable. There are a lot of built-in functions in R for the mean, for the standard deviation. So for the height in meters, we could also calculate the standard deviation and use this function. And by running this, this first function, summary, will show you the minimum value, the maximum value, the first quartile, the third quartile, the median, and the mean. And the second function only gives you the standard deviation, or you could also ask for the mean of data and heights in meters. So now we have, so for getting summary statistics, this is useful to run your code. But what you can also do is run the code inline. So instead of doing a code chunk, you could also write in your Rmarkdown document the average height is, and then you could inline write R code and use the same function as you used here. And when you rerun this code, when you knit it again, it will show this result in text. So it will update my presentation that I just made, and I need to refresh. You see here, the average height is 1.651. So that means that creating a document or writing a paper, that you can have these variables which come directly from your analysis integrated into your document, which can be a presentation, but it could also be a research paper for that matter. And it's a variable, so if I want to reuse this, I could also create a variable and use that variable. So I could also say here average height, and instead of recalculating this at this point, I could just use the variable that was created here. So that makes it very flexible and very reproducible in the sense that you could integrate the source of your analysis with the actual documentation that you are writing. So let's re-knit this again, and it will have the same results in our output. If we refresh, we still have the average height is 1.6, and I can reuse this variable at different points as I wish. There are also different packages that can be used to output in one summary, not just the min and max, but also the standard deviation. Or you could combine these functions together, but it goes out of the scope for today because I just wanted to show you some things that are possible within our studio. So, for example, the frequencies, we can use a histogram function. And as you can see that I can use the histogram again on the same heights in meters. So I'm just copying this one. If I'm going too fast, just tell me, right? I will replace the data that I used earlier. And I've added something. It's col red. So within the function histogram, there is the option to set the color to a specific value. So I changed the color. So in this case, I will have a histogram with a red one. Here we go. And within each function, and that's again because we're using Rstudio, you could have different options. So there's also breaks. Breaks means the amount of bins that you will show in your results. So we could set this to 2. Any idea what will happen now?
Have only 2 bars.
Yep, exactly. But it has so few data points that it still manages to do 3. So we didn't expect this, right? No. Let's do 4. Does it always do 1 more than we specify? Looks like it, right? Yeah. So I didn't know this. Here we go. So if you want to create a histogram, this is the function that you can use for this. We could also create a bar plot on the variables that we are interested in. Same again, just take the variable that you are interested in, plug it in, run the code, and here we go. We've got an outlier at the 180. Shall I guess? Hans, is that you?
Yes.
Yeah, I thought so, right? Cool. So, bar plots, and of course, we can do correlations. So you could use the correlation function that I showed you earlier, and if you look at the syntax at the code that is needed for this, it's again specifying that you want to get your use the data frame that we specified earlier. It's data, and we want to data. And what shall we correlate? Height against kilograms or something?
Yeah.
Let's do it. Let's do height against kilograms. Data and kilograms. And we can get the correlation. That's pretty high. Now, of course, we want to see this correlation also. So maybe we could put this in a plot. And that brings us to the graphing, of course, the graphing capabilities of R. It's quite easy to just specify plots, specify the variables that you're interested in, and it will create a plot for you. And you also have, for the plot function, because the plot function is a very generic function that you can use, you have lots of customization options. So you can create a header, you can create, can customize your X and Y labels, you can customize the scaling, you can customize the color, background color, so everything is customizable. So essentially what I do in my research papers is just create the graphs that I want to have in my research paper, style it in code, then export it as a PDF, and then integrate it straight away into a research paper, for example. So that's creating the plot. And all the while, I'm just adding some, I'm just changing some values in the code. But if I reknit my presentation, I get the total upgraded presentation that I started out with, only this time for the dataset that we specified together. We have our histogram here, we have our box plots, we specified the correlation, and we have visualized our correlation. So it integrates seamlessly into the presentation mode that you want to use. Is that clear up until now? Any questions on this? Yeah. You found the thumbs up. That's always a good one to see. Okay. So the final step in the last few minutes is that, of course, it's one thing to get just some frequencies and plotting your data. We also like to use R for modeling our data. So if we want to make statistical models with results, then we can use, for example, regression analysis, logistic analysis. Everything is possible within the framework of R. And so what we can do is, with regression, it really is quite simple. It is run using the function lm. Anyone has does anyone have an idea what it stands for?
Linear model.
Yeah, that's it. So we apply the linear model function, and then within this function we set our output value, so the thing we want to predict. We use the tilde, and we set our predictor, and we specify the data set. So this function has uses the naming of data for assigning your data frame to this, and in our case we used the same name, so I hope this works. So data is data, that's a bit weird, but and then we only have to use the column names instead of specifying our data frame first and then our column name. So we could have, and now I have to cheat because I have to look it up. I can use names. It's a nice function, data, and that will show me all the column names of my data frame. I want to do height in meters again. I want to predict height in meters by the weight. Height in meters by weight in kilograms. Copy and paste. I don't think I need this anymore. Yeah. And this will run us the linear model. So what we did here is specify the model. And if you have multiple variables, you could also extend your model. So I don't just want to predict the height in meters by weight, but I could also add, just by using the plus sign, more predictor variables. Or you can use the multiplication sign to do interaction, or to do, if you want to have the main effect and the interaction, you could add that too. So it's very extensible. So for example, in SPSS, if you want to do a moderation analysis, you have to have this extended package. In R, if you want to do a moderation analysis, you just specify your predictor variables and add an interaction term and you're done. So it's quite straightforward to do this. Now the only thing that's just a bit it's not that informative is what the initial results of your linear model spits out. So it spits out the I've assigned the results of this thing of the specification of the model to the variable fit. And if I look at the variable fit, I see that I get my intercept and I get my beta coefficient for weight. And sometimes you just want to see a little bit more. So if you apply the same summary function that we used earlier to the results of the linear model, then it will result in a bit more information. So this is more like the SPSS and the Stata output, where you have the estimated intercept, we have the estimated beta coefficient, you have the coefficient, you have the standard deviations, you have the specific test, the t-test for your beta coefficient, and you also get some information on the R squared value, so how much variance is explained by this model. And finally, the test of the amount of explained variance, the significance of the amount of explained variance. So applying a linear model is quite easy in this sense. We also could finally add, for example, the regression line to a plot, and that would actually entail just combinations of what we've done earlier. So if we would plot the data weight against the data height, we can use the function called appline and apply just the result of our model, the fit, and have the correlation, the regression line just added to the scatter plots. And this you could output as a PDF or what have you to use in your research papers. So we knit this entire thing, and that would result in a completely updated results. This was just a correlation. We talked about regression. We showed that you could have a summary of your entire regression analysis. And we've plotted this entire thing here. And that's about the scope of what you can do with R and R Markdown, especially integrating this with your presentations or results. And before we wrap up, I just wanted to show you, for example, that for my own lectures, I use this R Markdown integration just to create my own lecture. So I've got my lecture in the public domain in the GitHub repository, where I have my courses, where I have specific topics, so all the different topics that we cover within the course that I give are all are all stashed in these folders, and these just contain Rmarkdown files and results. And within the courses, I combine certain topics that I want to cover within my course, and that will result. For example, this is my most latest course. For example, if I want to do the moderation analysis, so this is a lecture on moderation. It's all written in Markdown. I've created two outputs, not just the presentation, but also the handout for the students. So the students, I provide the students with the handouts, which is in the straightforward form. And I also, for myself, during the lecture, have my slides available for the moderation analysis, where you also combine. I thought a few of you did a LaTeX course yesterday, I think, where you can also just combine the LaTeX for writing your formulas, and combining that with the results in R, and not just have static output like a scatter plot, but also make interactive charts, which you can just turn around, zoom into during your presentation to make it more clear what you're actually doing within, for example, a moderation, where you have the specific parts of the moderated values where you want to look at, want to know what it is to actually fit a two predictor model. So if you add the regression in such a three-dimensional space, what does the regression plane look like? And then you can actually show to students what a regression plane looks like within your presentation. So the Rmarkdown makes it possible not to only have static output, but also combine this with more interactive output for your students. So it's not just these graphs, but you could also have Google Maps, where you overlay certain areas, and you use code for that, where you can not just overlay the area, but have the overlay based on for example, on your data. So certain areas should have a heat map on it, or something like that. So these are all options that are available to you if you start using R and Rmarkdown for your research and education. And this means that we're getting to the end of this. So it was my goal to just show you what is possible, to get you at least some feeling of what is possible. The only way that you are going to learn this is if you get enthusiastic about this and start trying and finding out how it's useful and playing around, essentially. So just anything else?
Thank you very much.
You liked it?
Yeah.
Thanks. I hope it catches on to you and you want to go into programming R. It's really fun.
Thank you.
Bye.